Now I'm going to walk you through a couple of stoichiometry problems that were given on the assignment earlier last week. One that I was asked to show the solution to is number 12. So here's the problem. When 32 grams of oxygen reacts with 23 grams of ethanol, what is the limiting reactant, and what is the theoretical yield in grams of carbon dioxide? So, first of all, we need to start with a balanced chemical equation. Right now, this is not balanced. So if I look at the ethanol, C2H5OH, I see that there's 2 carbons, and if I want to put a 2 here, that will give me 2 carbons on that side. And then if I look at the hydrogens, I have 5 hydrogens plus 1 on the left, so that's 6. And on the right, I only have 2, so I'm going to balance that, put a 3 there for 6. And now for the oxygens, we have, on the right-hand side, we have 4 oxygens plus 3, which is 7. And on the left, we have 1 in the ethanol, and then 2 over with the oxygen. If we have 6 plus 1 is 7, there we go. So that balances it. Okay, the next thing that we do is we say, okay, well, we have 2 numbers here. We have 32 grams and 23 grams. So I'm going to label these just like we've been doing. So we have 32 grams of oxygen, so I'm going to put that below the oxygen, 32 grams of O2. And we have 23 grams of ethanol. So 23 grams of, I'm going to shorten it here, eth. All right? And we're being asked to find what the theoretical yield in grams of carbon dioxide is. And that is the CO2. All right, so essentially what we have here are 2 stoichiometry problems. I'm going to start with the first one with ethanol. So we have 23 grams of ethanol, and we need to convert that to moles. So we use our periodic table, and we determine that the mass of a mole of ethanol is 46.08 grams, so that will go down here. And that's for 1 mole of ethanol. Okay, so far my units of grams of ethanol will cancel. And then we want to go to the mole ratio. So moles of ethanol is what we're trying to get rid of, goes on the bottom. And we're interested in carbon dioxide, so moles of CO2 will go on top. Okay, and then this is a 2-to-1 mole ratio. That cancels, and we're left with the number of moles of CO2 that could be produced, which in this case would be 1.0 moles of CO2. And now we're going to repeat this process. That's 1, but now we have another reactant, and that's oxygen. So we have 32 grams of oxygen that's given. And the mass of 1 mole of oxygen, remember oxygen is diatomic, so it's not 16, it's actually 32 grams of oxygen. All right, and then that will cancel out these units here. And then we want to go to moles of CO2. So again, it's 2 moles of CO2, but now this time we have a 3 in front of the O2. So 3, let me fix that. 3 moles of O2. All right, so now we have a cancellation. And we're left with 0.67 moles of carbon dioxide. So now we look at these and we're like, okay, well, one of these is smaller. And the one that's smaller is the 0.67 moles of CO2. Which means the limiting reactant was our oxygen. So oxygen is our limiting reactant. We're not quite finished yet, though, because we need to figure out what the theoretical yield in grams of carbon dioxide is. So now we take this 0.67 moles of CO2 and we convert that to grams of CO2. All right. So we have our 0.67 moles of CO2. We use the periodic table to find the mass of 1 mole of CO2 and find it to be 44.01 grams. The units here will cancel, and we'll be left with 29 grams of carbon dioxide. So that is what the theoretical yield of carbon dioxide would be. The next problem that was asked to be shown the solution to is number 15. So 15 says to prepare the paint pigment chrome yellow, which is PbCrO4, a student started with 5.552 grams of lead 2 nitrate. The actual yield of chrome yellow was 5.096 grams. Calculate the theoretical yield and the percentage yield. All right, so let's write down, well, we have the equation here, but make sure it's balanced first. So let's see, we have 1 lead, 2 nitrates, 1 nitrate, so we'll put a 2 here, 2 sodiums, yes, chromates. All right, so that balanced it. That one was good. All right, and then let's write down our given information. So we have lead 2 nitrate, 5.552 grams of lead 2 nitrate, and that is this. So I've written down my givens, and so that's what was given, that's what was started with. And it says the actual yield of chrome yellow was 5.096. So chrome yellow is this PbCrO4 stuff here, and the actual yield was 5.096 grams. Now we'll need that in order to find the percent yield, but first we need to find the theoretical yield. So the theoretical yield is what this stoichiometry problem is going to start with first. So we want how many grams is that? All right, so let's get to it. We have our given, which is 5.552 grams of lead 2 nitrate. And we want to change that to moles. So we need the periodic table, and we find that when we add everything up, we have a mass of 331.22 grams of lead 2 nitrate. Remember, there's a parenthesis here, so there's 2 nitrogens and 6 oxygens, and that's for 1 mole of lead 2 nitrate. And that will cancel out the units here. Now we have our mole ratio step, so there's 1 mole of lead 2 nitrate for every 1 mole of our pigment chrome yellow. Those moles cancel out, and we can go straight to grams here. So I'm going to continue this on the next line here because I've run out of room, and I see a lot of you do this too, and that's perfectly fine. It's just ran out of space. So 1 mole of lead 2 chromate is what that is, has a mass of 323.20 grams. Okay, and then the moles cancel. So we work this out to be 5.418 grams of our pigment yellow here. All right, so that's our theoretical yield. And now you're asked, well, what is the percent yield? Okay, so percent yield is the actual divided by the theoretical times 100. So we have our actual, which was given previously as 5.096 grams. Oops, added another number there. Okay, and then our theoretical yield, we just calculated. Probably can't see that very well, so let me change colors. There. And that was 5.418. 5.418 grams, and we multiply that by 100, and we get 94.06%. So that's our percent yield. There you go. Let me know if you want to see any others worked out. I'd be happy to do this. I'll see you in class. Bye for now.